All right, guys, we're going to continue to talk about probability and probability rules. A lot of the stuff in this chapter is going to be example-based, and with probability, the more examples you do, the better that you'll get with it. But we'll go through some of the notes and some of the things that you need to go down, and then we'll do a lot of examples during class. So we previously, in our last lesson, we used simulation to imitate chance behavior. But as we saw last class, simulations can get a little bit tedious and time-consuming and can be a little bit difficult and annoying to do. So most of the time, what we'll do is we'll find the theoretical probability of doing something. And we won't have to do a simulation to find that. So the sample spaces, or the sample space of a chance process, is the set or the list of all possible outcomes. A probability model is a description of some chance process that has two parts. The sample space, so the list of all the possible outcomes, and then the corresponding probabilities for each outcome occurring. So for example, if we say what's the probability, or we're finding the probability of eye colors, our sample space would list out all the possible eye colors: brown, blue, green, hazel, whatever, other. And then we would put the corresponding probabilities to create the probability model or probability distribution. Here we've got an example that we'll go through in class. What probability models allow us is they allow us to find the probability of any collection of outcomes. So we might want to know the probability of rolling a 4 or a prime number, okay? An event is any chance or any collection of outcomes from the some chance process. So your event is a subset of the sample space. And again, this is all vocab type stuff, so you have an understanding if you hear any of this stuff. But once you go ahead and actually find these probabilities, you'll know exactly what you're doing. And we use capital letters when we're describing probabilities. So if we wanted to describe the probability of event A occurring, we would write it with P and then in parentheses A. Some important things to consider and basic rules of probability. First thing, the probability of any event is somewhere between 0 and 1. You can't have a probability that's negative. You can't have a probability that's above 1. Obviously, a probability of 0 never occurs. So that would be saying, like, what's the probability I have a student that's 30 years old? 0. Probability equal to 1, it always occurs. I'm not worried about the notation for a lot of these things here. So all of the probabilities together, or all the possible outcomes, must have probabilities whose sum is exactly 1. So the sum of all the possible outcomes must be equal to 1. I'm not worried about this in here. We can skip this part here. Okay? The probability that an event does not occur is 1 minus, the probability that the event does occur. So if I want to know the probability of somebody not having blue eyes, I can just do 1 minus the probability of having blue eyes. This is what's called the complement. So when you see A sub E, that's the complement of A. And the probability of the complement, okay, of that event not occurring is 1 minus the probability of the event occurring. If two events have no outcomes in common, the probability that one, this is a key thing, or, the word or in probability represents some, or the other occurs, is the sum of their individual probabilities. So if I want to know what's the probability that somebody has blue eyes or green eyes, and we're going to say nobody has two different colored eyes, I can just add those two probabilities together. The probability of blue eyes plus the probability of green eyes. That notation for that is important here. Okay, the probability, and I'm going to use a special type of notation here of A or B occurring. And that symbol right there represents the union. And that means the word or is equal to the probability of A plus the probability of B. This is our addition rule for what we call mutually exclusive events. And mutually exclusive just means that the two events have no common outcomes. We're going to see another addition rule later on. Again, some more examples that we will look at in class. So to further define what mutually exclusive events mean, two events are mutually exclusive or disjoint if they have no outcomes in common. They cannot occur at the same time. Okay, they can never occur together. So for example, being in block 1A statistics and being in block 1A gym are mutually exclusive events. You can't be in both. This occurs if the probability of A and B is equal to 0. Okay? They cannot occur at the same time. And we'll look at some Venn diagrams in the remaining example in class for that. Another example that we'll look at in class will end up leading us to the general addition rule for two events. And the general addition rule is what we use when the events are not mutually exclusive. Okay, when our events are not mutually exclusive, we use the general addition rule. And that rule looks like this. The probability of A in that same symbol or B, that's what that means, is equal to the probability of A plus the probability of B minus the probability, and again, I'm going to give you a new symbol here. That means and, minus the probability of A and B. And this part right here is the overlap. So for example, if I want to know what's the probability that somebody has blue eyes or blonde hair, I'm going to take the probability that somebody has blue eyes, I'm going to add that to the probability that somebody has blonde hair. However, there are blue-eyed, blonde-haired people that I've now counted twice. So I have to subtract that group out, which is what this part in here is doing. All right, so when you're dealing with the events that are not mutually exclusive, remember to subtract out the overlap. If they're mutually exclusive, the reason we're not subtracting anything out is because there is no overlap. The probability of A and B occurring is just equal to 0, and there's nothing to overlap there. That's what this example down below is showing, which we're going to see in some of the examples that we do in class. That's all in terms of the notes I want you to have down. Lots of examples with probability coming in class. See you guys.